All right, we are doing 11.4, which is, we're still talking about these formulas with sequences and series. We're still in the geometric, but now we're looking at something called an infinite geometric series, which means they go on forever and ever. Now, some of them we can add up, and some of them go on forever and ever, and when you add them up, you get infinity. So I'll talk about the difference between those two. Okay, so looking at these right here, we've got a pattern. We've got 29, and then 9, and then 3. So what's the pattern happening here? You're dividing by 3 or multiplying by 1/3 each time, right? Okay. So we can add this one up. This one is 9/4, 3/2, and 1. What's happening there? What's the really easy way to find our common ratio? We should know this. If you have a list of numbers and it's geometric, how do you easily find the common ratio? Take the second term divided by the first term. Okay, so we could have found that on this one. Take 9 divided by 27 and you get 1/3. So that's what you're multiplying by. Okay, so this one right here, if we take 3/2, we divide it by 9/4, what do we get? 2/3? Okay, so this one's 2/3, this one's 1/3. Okay, so these right here, the numbers are getting smaller. Do you see that? If the numbers are getting smaller, we can find the sum. Okay, so give me an example of one that wouldn't work. A geometric sequence. So 1, okay, so if your common ratio, what's the common ratio here? It's times 3. Okay, we can also find that by taking 3 divided by 1 or 9 divided by 3. Okay, so what's the defining difference between the common ratio of the ones we can add up and the ones we can't add up? Fractions, yes, but more specifically. So there's something in common with these two common ratios that's very different from this, besides the fact that they're fractions.
They aren't going up.
The numbers aren't going up, so what's true about the common ratio in those ones where they're getting smaller? It's less than 1. Okay, so the common ratio is going to be smaller than 1. Okay, so you can't just say fractions, because you could have a common ratio that wouldn't work, that would be like 3/2. Because if you're multiplying by 1.5 each time, your numbers are getting bigger. Okay, so you need to have a common ratio that's less than 1 so that your numbers are actually getting smaller. All right, and we just talked about this. We can find the sum of an infinite geometric series when r is less than 1. And we should actually put r in absolute value, because -40 is less than 1, but those numbers we wouldn't be able to add up either. Okay, so convergent, this is going to be part of your homework, these two vocab words. Convergent simply means that you can find the sum because the numbers are getting smaller, your common ratio is less than 1. And divergent simply means that they're getting bigger. And they can be getting bigger towards the positive or bigger in a sense towards the negative. But if they are getting closer and closer to 0, then we can find the sum. Okay. So here is our formula, our last one. So right here, notice that these numbers are getting closer and closer to 0, so we can find the sum. And all we need to do for the formula is take the first term on the top, and on the bottom, let's put parentheses around this. On the bottom, take 1 minus the ratio. Okay? So looking at this one, the sum of the infinite series. We put our first term here, and then 1 minus the common ratio. Well, what's the very easy way to find the common ratio?
T1 minus T2.
Not minus.
T1 divided by T2.
Oops.
No, T2 divided by T1.
Okay, so if we simplify this, what do we get? Okay, so we put that here, and then we put it in the calculator. What do we get? Thank you. Forgot my negative. What do we get? 81? Are other people getting that? I think it's 16.2. Okay, now let's think about this. This series literally goes on forever and ever and ever. So how in the world could we come up with one single answer for it to add up to? Well, if you think about this, this list of numbers is going to keep getting smaller and smaller and smaller and smaller, eventually to the point where the numbers that you're adding on are so crazy small that it's not really going to affect the total. Okay, so yes, it does go on forever, but this number, the 16.2, is really as close as you're going to get to that total sum. Now, if the numbers are getting bigger and we keep adding on bigger and bigger numbers, what do you think the total would be?
Much larger.
What would we say is our answer? Infinity. Okay, so if your numbers are getting bigger, your answer is simply infinity. You don't have to use the formula. Okay, so let's look at this one. What's the answer here? Infinity. Okay, this one. We're going to use the formula on this one?
Yes.
Okay, numbers are getting smaller. So we put our first term up here, and then 1 minus, what's the common ratio? 1/2. We take 12 divided by 24, and what do we get? 48, I believe. Questions? All right, let's try one of these. All right, so you know it's an infinite sum because there's infinity up here at the top. So we have our formula. All we need is the first term and the common ratio. So whenever we're doing these sigma problems, the common ratio is whatever has the exponent on it. So we already know that the common ratio is 1/4. Okay, which works because it's less than 1. So we know that we can use the formula. Now, how do we find the first term whenever we're doing a sigma problem? Whatever's on the bottom here, we put into the formula, and that'll give us our first term. So if we have 3 times 1/4 to the 0 power, that's going to equal what? This right here turns into 1. So 3 times 1, we get 3. So what do we get for an answer here? Is it 4? I think it's 4. Now, one last thing before you get to your homework. If we had negative signs, so negative 256 minus 320 minus 400 minus 500, what do you think the answer would be? Now you may think of these numbers as getting smaller, but they're getting bigger in the sense of negative numbers, right? Okay, they're going to keep getting bigger and bigger with a negative attached to it. So what would that add up to? Negative infinity. Okay, so keep your eye out for situations like that. Okay, they have to be getting closer and closer to 0 in order for us to use the formula.
That's good to know.
Okay.